2003 grade 11 Hypatia math contest. 1A. Quentin has a number of square tiles, each measuring 1 by 1 centimeters. He tries to put these small square tiles together to form a larger square of side length n centimeters, but finds that he has 92 tiles left over. If he had increased the length of the larger square to n plus 2 centimeters, he would have been 100 tiles short of completing the larger square. How many tiles does Quentin have? We are given a 1 by 1 tile, right? And then they're saying that they're going to make this n by n space or tile or larger square. So we have to take the information they've given us in the question and make it into an equation. Well, from this, we can get that the area is going to be n times n. But it's 92 tiles are left over, so we have an additional 92. And that equals the total number of tiles, which I will call x, because I don't know. That's what we're trying to figure out, actually. Okay, that's the first part. The second part, the second sentence, is that they are saying that they increase it now to a n plus 2 sided square. So now the area would be n plus 2 times n plus 2, right? But this situation is 100 tiles short, so we have to subtract 100 from that, and that is equal to x. So that's basically the setup, and then now it's just solving these two equations. So here we go. Let's see here. Well, this is equal to x, that's equal to x, so I guess we just set them equal to each other. So n squared plus 92 would be equal to n plus 2 squared minus 100. Okay, let's solve this, I guess. So n squared plus 92 is equal to n squared plus 4n plus 4 minus 100. The n squareds cancel, so that's good. And then 4n is going to be 92 minus 4 plus 100. So that looks like what? 188, I think. Yeah. And then that's 4n, so divide through by 4, and you will get 47. And, oh, I got to figure out x. I was thinking, okay, am I done? No. X is equal to n squared plus 92, so 47 squared plus 92. And that looks like to me 2301. And that is the answer to this question. And then what you can do is go back and plug these numbers in to test that it all works out. So I encourage you to do that just to make sure that you are correct. All right, so now we are moving forward to part B. Part B says, Quentin and Rufus arrive with a big pile of identical blocks, each in the shape of a cube this time. And then Quentin takes some of the blocks and Rufus takes the rest. Quentin uses his blocks to try to make a large cube with 8 blocks on each edge, but finds that he's 24 blocks short. Rufus, on the other hand, manages to exactly make a large cube of blocks. If they use all of their blocks together, they're able to make a complete cube, which has a side length that is 2 blocks longer than Rufus's cube. How many blocks are in total? Okay, so this question is a little bit different. So let's see here. We've got this is a cube this time. It's not a flat square. So we're going to give it a side length. They don't give it a side length, I don't think, in this question. So, and then the total number of such cubes I'll call x. So Quentin and Rufus, right? Those are the two. So we'll say that Quentin gets n, and then Rufus would get the other, so x minus n. And then in this question, we're trying to find x. How many cubes are there? Okay, so based on the question, we have to set up equations, just like how we did last time. We have to set up some equations based on the sentences. So the first one says that you're going to make this big cube a bigger cube, and that is going to be 8, right? Yeah, 8 Yeah, 8 blocks on each edge. Okay, so that means if this is S, this is going to be 8S. But then it's 24 short. Yeah, 24 short. So in an equation, it would basically be 8S. We're figuring out volume this time, so it's cubed, minus 24 short, and the volume of each of these guys is S to the power of 3. And that is equal to the volume of all the cubes that Quentin has. And he's got n of them, and each of them has a volume of S to the power of 3. So that's basically the setup of the first one. The second sentence basically says that now if Rufus makes a cube or tries to make a larger cube, he will have exactly enough. So that means he takes his x minus n cubes, and each of those has a volume of S to the power 3. It'll be exactly enough to make a cube. So let's say we have another cube with ms as the side length. So it would be ms to the power of 3. This was 8s, but we're not told how many there are, so that's why I wrote m, because I don't know. So that's the equation there. And then the final equation is basically a cube that is 2 more than this. So that was 8, so this is 10s. And therefore that total would be 10s to the power third in terms of volume. And that is if you took all of them. So you take all of them. So x, and then each of those is s to the power 3 in terms of its volume. So there you go. Those are the 3 equations. And we have to now solve these 3 equations. Okay, so let's see what we get. In this one here, everything has s to the power 3, I believe, so I can cancel those out. And then 8 to the power of 3 is 512, minus 24 is equal to n, I believe. Yeah, so n is equal to 488. Okay, that's good. I mean, so far it seems good. Okay, let's move forward to this guy here. Let's see. The s to the power 3's will cancel, so I'm just going to have m to the power 3 times x minus n. And then m to the power 3 is going to be x minus 488. Okay, so that doesn't really give me anything, but I can experiment. So basically, x minus 488 is a perfect cube. So let's see, what are perfect cubes? 7 to the power 3, 343. That's not going to help. 8 to the power 3, that's 512. So 512 minus, if x was this, I'm just experimenting. 512 minus 488 is what? 24. 24 is not a perfect cube. Let's try 9 to the power 3. That's 729. I don't think that gives a perfect cube. 10 to the power 3, that gives 1,000. And then 1,000 minus 488, if we were to plug in there, is 512. And 512 is a perfect cube. So it's possible that x is 1,000, but I'm not sure yet. I mean, it works out, but who knows, right? Let's just concentrate on the last one. The last one hopefully will give us the concrete answer. So this is 1,000, and then the s cubes cancel. Oh, look at that. In a very simple, straightforward way, we got the answer. I thought it was going to be a little bit more complicated. Okay, so my conclusion is that x is equal to 1,000. Not that we need to, but just to be complete, n is 488. And oh, okay, you're going to plug it into here. So 1,000 minus 488 is 512, and then the cube root of 512 is 8. So, all right, and I think this is all they were asking for. So that completes the question. Number 2, Yolanda and Xavier are playing a game starting with some coins arranged in piles. Xavier always goes first, and the 2 players take turns removing 1 or more coins from any one pile. The player who takes the last coin wins. If there are 2 piles of coins with 3 coins in each pile, show that Yolanda can guarantee that she always wins the game. All right, so we've got some experimenting to do. We got Xavier and Yolanda. And I'll just write 3 coins in pile 1, 3 coins in pile 2. That's the starting point. And then eventually, we have to get a situation where Yolanda is able to remove the last coin. So she's going to have there's going to be 1 coin left, and she gets to remove it. Okay. So I think the only way that's possible is to have Xavier have a scenario where there's only 2 coins left, but 1 coin in each pile. So because if that happens, he has no choice but to remove 1, and that's how you get into this final situation. So our goal is to get 2 piles with 1 coin in each pile, just like I have shown here. Okay, so how do we do that? All right, so there's going to be several scenarios here. Probably not several, probably only maybe 3, I think. All right, let's see what happens. Okay, so if we're going to start with what happens if Xavier removes 1, if he removes 2, and if he removes 3. So there's going to be 3 scenarios, I believe. Let's say he removes 1, right? That way, we are now into this scenario. And now at this point, Yolanda has to have a strategy that allows her to eventually get down to this scenario where she can just remove that last one. So her strategy will be as follows. She will remove 1. Okay, so then Xavier now has got 2 piles of 2. Now he still has a couple choices. He can remove 1 or 2. Let's say he removes 2. If he removes 2, then Yolanda can just remove the next 2, and then she wins because she removes the last coin. I mean, she's removing 2 coins, but she's also removing the last coin. That's scenario 1. But if you go back here, Xavier could have removed just 1 coin, right? Like he could have removed that. Then Yolanda is in this situation. If she's in that situation, she removes 1. Xavier then has to go in this situation. He has no choice but to remove 1, and then Yolanda can win. So that is the strategy. And this strategy, this right here, I will call strategy 1. I'll just put that 1 right there just to show that that is the sort of the strategy when Xavier starts off by choosing just 1. Okay, let's say Xavier now, he decides that he's going to start off by choosing 2. Then how does Yolanda win? Okay, remember, Yolanda's got this is our end goal here. Okay, Yolanda, what she will do is she will also remove 2. And then look at that. Xavier now is in this situation. He has no choice but to remove 1, and then Yolanda can win the game by choosing the last one. So that is the strategy when Xavier starts off by choosing 2. And I will call that strategy, well, I guess, whatever you want to call it. I'll just call it strategy 2, I guess. Why not? Okay, and then we get to the final one, which is when Xavier starts off by choosing 3. He just starts off by choosing 3. Well, then Yolanda just chooses all 3 and then wins easily. That's the very straightforward one. We'll call that strategy 3. And I think that's it. So that's basically the answer to part A, that these are the scenarios. And you can explain this by writing it out like in sentences. Explain, what's happening. And the more detailed your explanation is, the more points you'll likely get. And the goal is to get full points. All right, so let's move on to part B. If the game starts with piles of 1, 2, and 3, explain how Yolanda can win the game. So something like that. 1 pile that has 1 coin, 1 pile that has 2 coins, and 1 pile that has 3 coins. Okay. So I'm going to keep this in the field because I believe strongly that what we just did is going to be used in the second part, in part B, that I'm just... So now what happens is we have a scenario where the first pile has 1 coin, and the second pile has 2 coins, and this third pile has 3 coins, right? And then we have to figure out how does, who's winning? Yolanda again, right? Is it Yolanda that's winning? Yeah, Yolanda's winning. Okay, so I think it's just basically going to be the same kind of thing, but I have to explain it. And there's going to be, I think, 6 scenarios here. Okay, here we go. So Xavier has several choices for his first move. Let's say he chooses just to pick one coin from pile 1. Then Yolanda is now in this situation. Now, at this situation, she will choose 1 coin from pile 3. At this point, Xavier is dealing with this situation, right? And look, it's exactly like this. So, from this point, all you have to do is use strategy 1 from above. This strategy right here. You'll see it's identical. See, Xavier has 2 piles of 2. Here, Xavier had 2 piles of 2. And then, whatever, if he chooses 2, then Yolanda can choose 2. If he chooses 1, then Yolanda chooses 1, then Xavier chooses 1, and then Yolanda chooses 1, and she wins. So, as you can see, part A is used to solve part B of this question. Okay, that's just one scenario. How about if Xavier starts off by choosing 1 coin, but from this pile? Okay, well then Yolanda is faced with this scenario, and she can just choose all of these guys, and then this becomes something like this right here. See that? So you just implement, use strategy 2. And it's very straightforward, as you can see up here, that you just would, Xavier would have no choice but to choose 1, and then Yolanda chooses the last one and wins. Okay, so that's basically how you're going to do it, but I'll do them all just to make sure that you get it all. Let's say, what do we want to do next? We're choosing 1, right? We're in the 1 sort of pattern. Okay, so he chooses 1, but this time from the third pile. So Yolanda is now in this situation. She can now choose that, and at this point, it looks again like this guy over here, where you had Xavier has 2 piles of 2. Again, Xavier now has 2 piles of 2, and at this point, you just use strategy 1 to win. Yolanda uses, well, whatever. I mean, a combination of what Xavier does and Yolanda does. All right, so we got 3 more, I believe. We exhausted the 1, picking 1. So now we're going to pick 2, correct? Yeah, we're going to pick 2. So Xavier now, let's say he picks 2. And the first one, he picks these 2. So now Yolanda is faced with this scenario. And what she's going to do is she's going to pick those 2. And then Xavier is now faced with this. And at this point, you use, well, you tell me which strategy. Strategy 1, strategy 2, or strategy 3? Well, it's strategy... You have 2 C's. Well, you have 1 C's, right? So strategy 2. There you go. And then we got a couple more. We're still in the 2. This was 2. So the only other way to choose 2 is to choose it from the third pile. So he uses those 2. Yolanda now has this scenario, and she's going to choose this. At this point, Xavier has this, and then we are back to something very familiar, and you use strategy 2. And then the very last one is the only time you can choose 3, and that's from the third pile, right? So C, 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 C. And then Yolanda is faced with this scenario. She will choose that. And then Xavier is down to 2 C's, and that is a strategy 2 situation. And that's it. So, like I said before, write this out in sentences, explain it, and that should be sufficient for this question. All right, so now, number 3. In the diagram, the sphere has a diameter of 10. The right circular cone has a height of 10. The base has a diameter of 10. The sphere and cone sit on a horizontal surface. If a horizontal plane cuts both the sphere and the cone, the cross sections will both be circles as shown. Find the height of the horizontal plane that gives circular cross sections of the sphere and cone of equal area. All right. So they've drawn a very nice diagram, so I don't have to. And they've even labeled it H. So I guess we just have to kind of go from here. All right, let's see here. What can I do? I think it's a similar triangle situation where if you draw a line from top to bottom like that, and then there, and then top to bottom there, well, it would be, I mean, this is 3D, so it'd be kind of like this. Yeah, it's a similar triangle, so let's see if I can label this. This little guy is H. This top from here to here, that's going to be, it's 10 minus H, right? Yeah. And then this is going to be R for radius, and that is 5 because it's just half of 10, half of the diameter. So using similar triangles, that means that 10 minus H over R is equal to 10 over 5, right? The full height over the full radius. Yeah. Okay, so that means 10 minus H is equal to 2R. Or R is equal to 10 minus H over 2, whichever one. Okay, so now we'll turn our attention to the circle. Let's draw a center in the circle, and let's see what we can label here. So we're going to draw that line, we're going to draw this line, and we're going to draw that line. And then, of course, let's just extend it down. So this is H. They even show you that over here. So this is going to be 5 minus H, right? Yeah, 5 minus H. This is the radius, so 5. And then this is R. I'll just make it a big R. It has to be the same, right? This R has to be the same as that R. That's the only way the areas would be the same. But let's just make it a large capital. Okay, so from that one we get a Pythagorean relationship because this is a right angle. And that would be that R squared plus 5 minus H squared is equal to 5 squared. And I think that's it. We got two equations, two variables, and we just solve. I don't think that's anything more to it than this. So yeah, these R's have to be the same. That's the only way the equal areas could be achieved. So this R has got to be the same as that R. So substitute it in. So instead of R squared, it would be 10 minus H over 2 squared. Yeah. And then expand this to 25 minus 10H plus H squared is equal to 25. Okay. I think that should be correct. Let's see here. So let's expand this. We get 100 minus 20H plus H squared over 4. 25's cancel and just get 10H plus H squared is equal to 0. And multiply through by 4 and we get 100 minus 20H plus H squared minus 40H plus 4H squared is equal to 0. Collect like terms. We have 5H squared minus 60H plus 100. Divide through by 5, we get H squared minus 12H plus 20. Okay, I'm pretty sure this factors very nicely. H, 10, 2, minus, minus. So that means H is either 10 or 2. Now let's think about this. If H is 10, that means the height is all the way to the top. And if the height is all the way to the top, the cross-section essentially would have an area of 0. Yeah. Because if H is 10, that means that R would be 0. So the area of that cross-section, which is pi r squared, would be pi times 0 squared, which is 0. So obviously H cannot be 0, so the only admissible value is H equals 2. And that would make R equal to 10 minus 2 is 8. 8 divided by 2 is 4. And therefore pi r squared would be 16 pi. So H equals 2 is the only height that makes sense. So therefore that's the right answer. Number 4. The square ABCD has vertices A, B, C, D, obviously. From point P outside the square, a vertex of the square is said to be visible if it can be connected to P by a straight line that does not pass through the square. Thus, from any point P outside the square, either 2 or 3 of the vertices are visible. The visible area of P is the area of the one triangle, or the sum of the areas of the 2 triangles formed by joining P to the 2 or 3 visible vertices of the square. Okay. Show that the visible area of P2 negative 6 is 20 units. Okay, so we have to just calculate the area of this triangle here. So area of a triangle is 1/2 base times height. Okay. The base, well, the base looks like it's going from an x-coordinate of 1 to an x-coordinate of 5, so that's 4. Okay. The height is going from a y-coordinate of 4 to the y-coordinate of -6. So from 4 down to -6 is 10 in terms of the distance, right? From there all the way down to there. So that's 10. And then therefore this is 20. And that's all they want. So that takes care of that one. Okay, let's move this up. So now they're saying show that this visible area is 20. Again, okay, I think same story here. This one and this one. So the first one, the first triangle, 1/2 base times height. And then we'll add to it again the second triangle, 1/2 base times height. Okay, so the first one, the base is 4, just like we showed last time. The height is from there to there. So we're going from a y-coordinate of 4 to a y-coordinate of 0. So that's 4. Right? Okay. Next one, height is this guy right here. And that's going to be 4 because it's just the side of the square. And it's going from a y-coordinate of 8 to a y-coordinate of 4. And then the height would be basically from here to here. So that would be x-coordinate of 5 to x-coordinate of 11. So that's 6. So this is 16 divided by 2, which is 8. This is 24 divided by 2, which is 12. And that is 20. So there you go. And finally, the set of points P for which the visible area equals 20 units is called the 20/20 set, which is a polygon. Determine the perimeter of the 20/20 set. Okay. So I think what we have to do is just concentrate on that square and then see what happens. And then we're going to kind of use part A, this guy, and part B to help us out a little bit. So in part A, we noticed that if we went down 10 units, so wherever this is, if we went down 2 units, like they showed us 2 negative 6, right? That the area would be 20. So what if I had just directly down like that and then directly down there? So this point would be, this was what? A, B, C, D. Yeah, A, B, C, D. A, B, C, and D. And I don't want to make this messy, so I'm going to write them up here. A, B, C, D. And I'm going to write the coordinates up there. 1, 4, 5, 4, 5, 8, and 1, 8. Yeah. Okay, I think that should be good enough. All right, so that means this one would be, since it's directly below the A, it would be, x-coordinate would be the same, so it would be 1, and then the y-coordinate would be -6, right? Because you're going down 10 units. And very similarly, that guy would be the same x-coordinate as B, so 5, and then -6. So if we were to draw a triangle like that, it's fairly straightforward that this has an area of 20. And very similarly, if you draw a triangle down from B, that triangle, that's also going to have 20. And then we've shown that a triangle like that also has an area of 20. So anything on that line, it seems like, will give you a visible area of 20. And that line has a length of 4 because it's going from an x-coordinate of 1 to an x-coordinate of 5. Okay. And because of the symmetry of this diagram, the same story holds true if you're going to draw that line out there, or the line out here, or the line way up there. See what I mean? You can just rotate it and see that the same kind of story holds true for what I did down here. So, and each of those, of course, have a length of 4. Okay, now they give us a very, very good clue that the shape is a polygon. So the only way this is going to be a polygon is if you connect it directly like that. And like this here. And they're kind of hinting at that in this part of the question, that they're kind of describing that if it does exist on these sort of diagonals, that you can also get a visible area 20. So they used 11, 0. So 11, 0 is somewhere, well, whatever. I don't even know where, but somewhere. Somewhere here, maybe, right? So I'm just saying that that's sort of and that's how they got kind of the scenario of 2 triangles. Okay, no problem. So we have to figure out the length of that because we're interested in the perimeter. So the distance from here to here. Okay, how do I figure that out? The distance from there to there. Do I use just? I think I just use simple coordinates. So this point here, if it's 10 units from B, right? Because this has got to be 10. So B is 5, 4. So 10 units on the x-axis would be 15. That, and then they have the same y coordinate as B, so 15, 4. And then this guy here has coordinates of 5, negative 6. Okay, so I just use the distance formula to figure out that distance. That shouldn't be that hard. Call it distance between this point and this point. So that's going to be 15 minus 5 all squared plus 4 minus 6 all squared, and then all under the square root sign. So that's going to be 10 squared plus 10 squared, and that's 200 root 200, and that's 10 root 2. Okay, so each of these diagonals, they have a length of 10 root 2. Because the symmetry of the diagram, everything's going to be the same. So the total perimeter would be 4 times 4 plus 4 times 10 root 2. And that looks to me like 16 plus 40 root 2. And that is the answer to this question.